Welcome to the fastest way to learn data structures and algorithms with this premium revision material. Today we are mastering LeetCode 58, the length of last word challenge. This is a classic string parsing problem frequently asked in interviews at top tech giants like Amazon, Microsoft, and Google. Let us look at the problem statement. Our task is to find the length of the last word in a string S, which consists of words and spaces. A word is defined as a maximal substring consisting of non-space characters only. For example, in the string hello world, the last word is world with length 5. But what if there are trailing spaces, like fly me to the moon? We need to skip those spaces and find moon, which has length 4. Think of the challenge here. A naive approach might be to split the string and find the last element, but that uses extra space for the list of words. To achieve optimal efficiency, we need a strategy that uses 0 extra space and scans the string only once. Imagine a perfectly organized library. You want to find the last book on a long shelf. If you start from the left, you have to scan through every single book to reach the end. But if you start from the right, you can quickly skip the empty space at the end, grab the very first book you hit, and measure it. That is exactly how we will optimize our solution. This leads us to our golden rule. The backward scanner strategy. Instead of scanning from the beginning, we start at the very end of the string. We skip any trailing spaces by moving our pointer backwards until we hit a character. Then, we start counting characters until we hit another space or reach the beginning of the string. This gives us the length of the last word without ever touching the rest of the sentence. Now, let us dive into the dry run. This is the most important part. Look at the screen. We have our input string at the top, and our counter variable on the right. Notice the caption box at the bottom tracking our steps. Let us trace the string. Fly me to the moon. Notice the trailing spaces at the very end. Our pointer starts at the last character, which is a space. First, we skip the trailing spaces. Look at the pointer moving left, 1 space, 2 spaces, and now we hit the character N. This is the end of our last word. Next, we start our count. Notice the counter variable incrementing as the pointer moves. 14n, 240, 340, and 44m. Wait, look at the highlight. The next character is a space. That means we have reached the beginning of the last word. We stop our count here and return 4. The logic is clean, fast, and precise. Now that we have walked through the logic visually, let us see how this translates into our Python code. We define a function called lengthOfLastWord that takes a string S as input. Inside the function, we initialize 2 variables, I, set to the last index of the string, and length, set to 0. First, we use a while loop to skip trailing spaces. As long as I is greater than or equal to 0 and the character at index I is a space, we decrement I. This moves our pointer to the last character of the last word. Second, we use another while loop to count the characters of the last word. While I is greater than or equal to 0 and the character at index I is not a space, we increment our length variable and decrement I. Finally, we return the length. It is that simple. Looking at the complexity, the time complexity is O of n in the worst case, as we might scan the entire string if it contains only one word or is full of spaces. However, in practice, we only scan the last word and its trailing spaces. The space complexity is a perfect O of 1, because we only use a few integer variables regardless of the input size. And that is the length of last word challenge mastered. Save this video for your next interview revision, and follow for more deep dive DSA explainers. Send this to your coding partner to help them level up.